How are we doing tonight? Okay, let's start with myself. I'm Eugene, and I've been working as a front-end architect at IBM for the past 2.5 years. So I know a little bit about the front-end architecture, I think. And tonight I'm going to try and share some of my thoughts and ideas with you. Let's see if anybody finds it interesting. So what is the web application front-end, and why do we need to architect it? Well, in the past several, I guess, decades, the internet has made a huge leap forward in terms of how it presents the information to the end user and what the end user is able to actually accomplish at the end of the day, using nothing more than simple HTML page, a bits of JavaScript, and some styling. Now, before that, all of that can happen, of course, the development takes place. And before the development can even commence, some architecture or a structure needs to be put in place in order to ensure that the end service is actually usable, maintainable, and makes sense to the end user. Can everybody hear me? Is it? Okay. It's just weird to like stick microphone right into it.
Shove it in there.
Show it. Okay. Okay, sure. So, all right, let's start. So, when the project is getting set up, now none of this is actually the architecture, but these are the good beginning steps for any project to undertake. And I'm sure anyone who has ever done the development is familiar with these keywords. So the project requires definitions, requirements, timeline, storyboarding, and so on and so forth. Now, why is this important? Because before you can actually understand what your project requires in terms of architecture, you need to have a good understanding of what the project is. What is it all about? Then and only then you can figure out how to tackle it in the best possible manner. So here I laid out some of the possible applications. They are actually all in-browser applications that you can access from your from the convenience of your browser that could help you get started, such as Draft.io, Envision, Zeppelin. All of that is there to make sure your project starts with the right foot. And now once the actual initial requirements, storyboarding, and timelines are in place, then you can start on architecting the front end and the back end. I'm not going to touch the back end today because I'm not the best person to talk about it. Well, I know a fair share, but I have only done the front end architecture so far. We are going to instead focus on initial research and the best setup for the job. So the front-end architecture basically boils down to us determining what pieces of the puzzle fit best into the project that we are about to execute. What frameworks we're going to be using, what libraries are going to be working behind the scene in a browser to ensure that the user gets the best, most performant, most beautiful, most convenient web service ever. And it all begins with deciding what package management solution you're going to be using. That basically lays the groundwork for the entire architecture from the beginning. It's like the foundation of everything. But what is a packager, you ask, and why do we need them? Well, in the recent years, the JavaScript that drives all of those beautiful front ends that you see on the web has become increasingly complex. In between those bits and pieces, it is virtually impossible to develop them all in one go, like one ginormous block of JavaScript, because it's all powered by JavaScript, as we all know. Instead, what the architects reserve to do is to break it up into smaller pieces and then at the runtime recombine them into that giant block of JavaScript. But that, of course, is impossible from the human perspective. That would be too tedious a work, though I have seen that done like manually in the past. And I have to confess, I've done that manually myself once. Right. So instead of doing it manually, we can employ something called a packager, which is basically sometimes something JavaScript-based, sometimes some other language-based software that would allow us to define to declare the pieces of our front end and how they're going to combine and interact with each other, and allow it to build them up in one convenient package that would be easy to deliver to the front-end user. Because we also have to remember that when it comes to the front end, we are always limited by the issues like the bandwidth, like the size of the payload, the size of our package, how big it is, how easy it would be for an end user to actually download all of this in the browser, because remember, it all runs on the user side. There are a few popular packages on the market right now. I have listed a few of them, just 3. All of them have their pros and cons. I worked with these 3 and some others in the past, but in the most recent years, Webpack has become more or less indispensable when it comes to the front-end JavaScript packaging. Now, the problem with the Webpack is that it's got a lot of things going on for it, and its setup and usage has become increasingly complex. So it's a bit too time-consuming to get it set up and all running as you want. Now there is also Rollup, which is another popular packager. It's a tad easier than Webpack to set up and configure, but it's lacking on certain features such as like dynamic library loading and so on. And there is also Require, which is like base of the base, most dumbed down packaging system ever, and all it does is just fetching things from the internet on runtime. That's a bit of a bandwidth hog, but at the same time, if your project doesn't require much in terms of the front end and in terms of the filing system and libraries, that could be also a good starting point for you. And once we've decided on a packager and set it up, we can move on to deciding whether or not we want a transpiler. What the heck is a transpiler? Well, the transpiler is an idiotic idea by someone to take one scripting language and transform it into another. Why to do that? Well, there are several reasons, actually. The front-end development has been historically tackled by not so very front-end oriented people. Majority of the time you will end up with a team of so-called, what is it called? Come on, suddenly it blocked. With a team of so-called, how you call a person who does back-end and front-end? Full stack, thank you, oh my goodness. It sometimes happens with me, it just like blocks, and I cannot remember for the life of me what the heck I was gonna say. Yeah, full stack. So what the full stack person is the guy who has done backend and for his entire life, and then figured out that the full stack pays more, and now he's applying as a full stack. He doesn't have a first idea of what the front end is all about. He thinks it's HTML, and how hard could HTML be, right? So the transpilers are there to make their life in your life a bit easier, because they allow them to write the JavaScript code in the in a way they have been used to writing the backend code, such as C#, C, C++, and so on, more or less. There are several transpilers out there which could be utilized. Now, you don't actually need a transpiler if you are a one-man show and you actually know what you're doing. But for the team, I found it personally that transpilers help, especially TypeScript. I don't like TypeScript myself. I think it's not a very good idea, but it seems to work. It seems to work, and it does the job. So you could actually give your backend people the front-end work, and they seem to be able to accomplish it, actually. And whatever they do for written works, which is the magic here. So the TypeScript, anyway, enough TypeScript. So there are several of the transpilers out there. TypeScript being the most popular, I think followed by CoffeeScript. Then there is also Babel, which is something that I would personally recommend. Why? Because the Babel is actually based on the future JavaScript standard that is not yet here, but will be at some point unless we all die out. Okay, so now that we've decided on a transpiler, what are we going to use? We can move to the next step in our architectural design, and that would be the styles. Now then, most of what you see in the browser, when you navigate to one of those fancy front-end one-page applications on the web, is actually styling. There is a minimum of HTML going on at the back. There is tons of JavaScript driving all of that monstrosity. But what makes it beautiful and acceptable to the eye is actually styling. And the styling on a web is accomplished, as you all know, with CSS, which is a cascading style script type, well, not a language, but a specification anyway. There are several ways to implement this specification, the most popular of which seems to be SCSS, which is like a derivative of CSS, but for some reason people think that it makes it easier to work with CSS. I tend to agree. Then there is also Sass, which is a bit weirder than CSS, especially for people who've only ever dealt with the C-style languages, because it's like missing all the brackets and everything has to be indented in order to work. That confuses a hell lot of everybody. And the most recent trend is delivering CSS from JavaScript itself, letting JavaScript generate it for you, which may or may not be a good idea, depending on how big your project is and how many components it involves. I would personally recommend to stay away from it for the larger projects, but for something smaller, actually styling the component itself directly in the component makes sense. Okay, so then there was a lot of things that I wanted to say about all the previous slides, including this one, but at this point I can't think to remember what the heck it was. Okay. Next step, once we decided on the first three, is how we are going to implement internationalization. We live in a very multicultural country here in Canada, thankfully. And in the life of every project, sooner or later, there comes a time when the big boss comes and says, okay, we've made everything is working perfectly fine in English. Now let's have it in French. And everybody's like, what? Seriously? We've just like hard-coded all the strings in English. Now we have to hard-code another like bunch of strings in French? And all of that is avoidable. That can be fixed with implementation of internationalization setup. Now that is a bit tricky, especially in today's context, but there are a couple of things that could possibly help you. If your project is in React, then React Intel seems to be an obvious choice. It's a basically helper component of the React that allows you to easily set the language and the translatable strings, normally fetched from the backend, but that's not the point. The React Intel is directly based on format.js, which is a good way to implement localization if your project is not utilizing React and using something else. I think Angular has their own implementation of it, but I couldn't remember what the heck it's called. And I think that's pretty much it when it comes to internationalization. At least I haven't met in my practice any other software solutions. A lot of projects that I have seen in the past actually implemented internationalization themselves from scratch. Okay. And finally, we have come to the most important part of any design of the front end, deciding on what framework we're going to use to actually implement all of that goodness. Now we know what the packager we're going to use, if any. We know how our styles are going to be integrated. We know whether or not we use a transpiler, and we have set it up. We have figured out our internationalization. Now is the time that we actually decide what the heck are we going to use. And here is very, very small list of what is otherwise a ginormous sea of garbage that is available out there. And what you're going to use basically should never be dictated how you feel about a certain project and what you like about it or don't like. It has to be a common sense to the decision. I personally hate React, but I would recommend React to specific projects where it makes sense. If you're building a UI, one-page interface with a lot of buttons, with a lot of smaller components on it, but which is not expected to change much, React is actually the best thing for the job. If your application is a bit more complex than that, then you would probably be better off with something like Angular or Vue. Then there are simpler frameworks such as Backbone, which basically just allows you to set up models for your views and generate the views at runtime from the models using jQuery and stuff like that. I'm trying to generalize things, and I realize that I am failing miserably because it's not that simple to just tell people about how things work. Especially if you don't know if they actually even understand you. The big question when it comes to frameworks is whether or not you actually want to use one. Somewhere on the internet I've come across the blog which strongly suggested that you should never use a framework, actually. Argumenting that the argument there was that if you need to build a bike, you don't need a car to build it. You can just build the bike itself. However, in my practice, it seems that the framework actually does help. It allows you to cut the development time significantly because it provides a lot of setup which otherwise you will have to do yourself. And if you would have to write every single piece of a front-end software and reinvent the wheel over and over and over and over again, you would have enough wheels to power the Big Ben of London at the end of the day. All of that can be avoided by implementing a proper framework. Now, which one? Once again, that very much depends on how the project is set up and what it's all about. Now that we decided on a framework, we need to think about what libraries we are going to utilize. And the rule of thumb here is that if you are not planning to utilize at least 60% of the library's capabilities, do not use it. When it comes to the front end, it's very, very important to keep the payload size to the minimum, because at the end of the day, your user will be the one impacted by the load times, and the JavaScript actually needs to be fully loaded and understood by the browser at the time of execution. So the more libraries you spit into your browser, the slower it's going to perform at the end. And when it comes to libraries, of course, there is jQuery, which has been very, very popular in the recent years. It's a scary thing because a lot of people got so used to it that they can't really do anything without it anymore. And that is very unfortunate because the jQuery in itself is very slow and very heavy. At least it has been like that until now. I don't know, maybe it has been updated. Then there is, of course, underscore library. And if I had a penny for how many times I hear I'll be using underscore to do this, I would be a millionaire by now. The underscore is another one like jQuery. It helps you do a lot of things with the data, much quicker than you think you would be able to do it without it. But that's not really true. Especially in recent years, JavaScript made so many advancements that you practically don't need all that functionality anymore. Then there is, of course, Bootstrap, a fantastic library to make very ugly UI. It works, don't get me wrong, but most of the time you would be better without it. And the list goes on and on and on and on. So the idea here is that you're only supposed to take the library in and incorporate it in your workflow if you're sure that you're going to utilize at least 60% of it. If it's less than that, you could probably write those bits and pieces yourself or take them out of the library and like do a bit of stealing. But that's open source, right? You can copy. All right, so the final step in our architectural journey is deciding on the standards. And this is where a lot of projects that I have seen fall short. The standards is basically force the developers to do code in a specific way. And the reason why this is so important is, especially for the larger projects, is because when you got lots of people doing many different components at once, and all of them are doing them in their own special, unique way, which is fantastic, everybody is unique, you end up with a lot of spaghetti code which nobody understands and is unmaintainable. So deciding from day one what your standards are gonna be is very important. Do you need semicolons? How many spaces is too many spaces? Is it tabs or spaces for the indents? And so on. What testing framework you're going to be using? All of those decisions are very important to make in the very beginning of your development. Now keep in mind that all of this has to be decided before even the first line of code is written. And I think this is the end of my presentation. I don't know how long I took because I don't have any time indicators around here. So I'm not sure if anybody's got any questions. It was pretty convoluted. I prepared last night, didn't have much time, but anyway. Yes?
What's your usual strategy for unit testing or just testing in general?
It depends on what framework you use.
React.
For React, that's probably...
Could you repeat the question, sorry?
I'm sorry?
Could you just repeat the question?
Oh, okay. The question was, what's the testing strategy? What is the usual testing strategy? The answer is it depends on the framework, and the gentleman says for React. Well, for React, it's basically Jest. I'm guessing that's it. That seems to be the most popular, but at the same time, there isn't really a right answer here because all of them seem to do one and the same thing. The goal of your testing is to ensure that certain components work. It's very difficult to do that with a declarative framework, especially because in order for you to actually ensure that what the component does what it's supposed to do, you have to render it. There is no way around it. And for that, you have to spin a headless Chrome instance or something like that. Yeah. Okay.